everyone. Welcome back to Dragonfly Engineering. So this week we've got a micro machining project to do. We're going to dice up this hypodermic needle into small sections that are 32 thousandths by 40 thousandths of an inch, or 0.75 millimeters by 1 millimeter in length. And to do that, we're going to use the EDM machine behind us. So I'll show you how we're going to do that. All right, let's pull this hypodermic needle stock out of the package here. This is 304 stainless. And let me see if I can get the focus in. So there's the end of the tube. Not sure if you can see it. I'll probably have to get the little USB microscope out to see. But the plan is to use 40 thousandths thick copper sheet metal that we're going to load onto the side of the sinker EDM machine, and then come down and dice out all of these tiny little tube sections to fulfill the order for the customer. We need to make a fixture with the mill and the vise over there to hold these this tube in place while the cutting action is happening. So basically we're going to pinch the tube above the toolmaker's vise with some sheet metal that we're going to form into basically essentially a long sheet metal version of a tweezer. And then that all is going to get clamped into the vise so that our tube is standing proud of the top of the vise, because we don't want to EDM cut 40 little lines into the top of the toolmaker's vise either. So that is the plan. Let's see if I can get the USB camera so you can see the details of this tube a little better. All right, I was able to get the laptop and the Dynolite USB camera, not sponsored by the way, in the frame here with our penny with Abe Lincoln there, just so you can kind of see the size of the tube. So here's our hypodermic that we're going to be cutting. So let me go ahead and just lay that on there. This camera doesn't have a variable focus, so you kind of have to fix the focus. But that's what we're cutting up. So let's get going on it. So the thought here is, let me zoom out a little, is to use some of this stainless steel shim that I have here. I've got two pieces, and I'm going to attempt to clamp the hypodermic needle into the top of the stainless steel like this, or let's see here. So we're going to have a piece of stainless steel with a little groove in it, which I'm going to try to cold forge in the vise, or we may have to machine a little tiny slot, and then the other piece of stainless will pinch the tube in place, and then this whole assembly will then be clamped into the vise in the EDM machine like so. And then the piece of copper, which I don't think I have one on the bench here, but we'll say this razor blade is a piece of copper, will come down and slice through this stack. So that way we're going to wind up holding a bunch of little tiny cylinders in this fixturing spring-loaded clamp. So let's try and see if we can create a little groove in the top of this first piece of stainless steel. I think we only need a groove in one side, and then this other piece of stainless will just pinch and hold our little tiny spacers in place. So let's go over to the vise and see if I can press in with this ejector pin a little D-shaped profile, which I doubt we can do because this stainless is already hard. If that doesn't work, then the next step is to try to bend a little V bend in the top of this stainless using the Curt 6-inch vise. So let's go over to the vise and see what we can do. All right, so we got our kit here, some Scotch tape to basically hold our forming die, which is our ejector pin here. We got our little forming die overlaid on the stainless, so I'm going to attempt to drop this tape over top of all of that, and we'll see how that goes. Maybe I should just launch straight down and hopefully everything sticks simultaneously. So let's see what happens. It was close, but I think I can adjust. So again, we want to get this rod as close to the top of our stainless as possible. Okay, so I think we've got it stuck reasonably well. May even wrap the tape around the top. Okay, so there we go. Here is our setup. Let's see if I can focus. Anyway, so I hope you can see that rod stuck on top of our stainless. Okay, so let's see if we can smash this profile in. So the idea now would be The yield strength of the aluminum is about 36,000 psi. The yield strength of our ejector pin here is probably 100,000 psi. The yield strength of our stainless is probably 60,000 psi because it's work hardened. So what we are going to attempt to do, oh, and then the strength of this old Kurt Vise, this strong jaw, I think is probably, I don't know, maybe 60 to 70,000 psi yield strength. So we're going to press this assembly up against the softest material, which is the aluminum, and we'll see what happens. Let me bring the vise in closer. And of course, you know, I'm using not new vise jaws since we're basically smashing things with it. So let me drop this in and see what happens. I'll probably have to step up to the original vise handle. Previously, I was using this step handle, but you can't get good torque on it. And this may not be good for the vise, but this vise has seen a lot of action. I think you can get about 1 ton of force with these Kurt vises. So let's see if I can press in. Yeah, this bottomed out pretty quick. So we may have to use plastic as our soft medium. But let's see what happened. And it doesn't look like a lot happened. I can see some deformation of the stainless, but it's not quite what we want. You can see a little bit of an imprint in our aluminum soft jaw, but not much. So, but fear not, because we got a piece of disposable plastic here. It's probably ABS plastic. And let's see if we can press our D-shaped profile into the plastic. So we got our hard soft jaw, our hard jaw on one end, and then plastic backing up the soft jaw on the other. And we'll get right kind of in the middle of the force range of the vise here. And yeah, okay, let's try this one. So I'm gonna go ahead and clamp down again. Yeah, we get more travel now. It's stuck to it. Okay, so here we're starting to pick up a dent in our stainless steel. Let's see if you can see that or not. Okay, so let's bring it down again. And we'll bend it some more. Okay, now we got a better shape there. I don't know if you can see that little kind of groove that we've bent into the stainless. So this may be all we need to fixture our hypodermic needle to EDM cut it. So let's go ahead and try to set up on the EDM machine with this piece of stainless and then another one that will hold our stock to cut. Okay, we're back over here at the bench. Here's the vise I usually use for the EDM machine. It's still got some EDM oil on it. That groove that we bent into our sheet metal, well, we're going to hold this guy about right like this. And then our hypodermic tube stock will fit right like that. You know, you can see this tube stock. So, but we don't want to EDM into our vise, so this all has to sit up a bit. And then here is our clamping piece of stainless steel. This came in a big roll of shim stock. So we're going to be fixtured about like that. I think another one of these will act as a parallel. So let me cut off another piece of our stainless shim, and I'll be right back. Okay, I'm back. So here's another piece of stainless shim, and you can actually bend these to create more of a support. I think they're called zigzag shims or wavy shims. But anyway, so we can stick this guy right there. We got another couple of bends in there. So you can mount that guy like that, and then when you close the vise, it'll flatten out. So you can support thin things because, you know, our parallel needs to be thinner than the actual parts that we're supporting. So let me clean off our top clamp here. I may have to tape all of this together, actually, so that it kind of stays together while we assemble it into our vise. So put our needle on and in our groove. This is all delicate fiddly work, like so. Okay, And then our top piece of our cap, our clamping cap, we will then put on. And move that guy a little bit. I don't have the steadiest hands in the world, as you've probably noticed, but let's see what we can do here. Oh, of course, it didn't work out. Small parts. I'll probably take a few takes on this. There we go. Okay, so here is our stainless, oh, and it just fell out. Oh well, I guess I got to keep pushing on it or pinching it. There's remnant EDM microspheres of steel in this vise. All right, here we go. Like that. So that is the view of our setup. Basically 2 shims holding our hypodermic needle. Let's see if I can focus right on the needle tip. There, look at that. Yeah, so the next step is to load all this assembly into the EDM machine. Okay, so the next step is to set up our EDM cutting tool. So I have a couple of options here. One is this cutter that I've used before. And for those not familiar, basically we electrify the copper and it creates a bunch of sparks and it burns through our steel part using a EDM milling process or an electric spark erosion process. And typically I use copper for that. So here is a tool I've used in the past. This is the holder that fits in the EDM machine. But we want to use a lot of, we're going to do a bunch of little cuts along this guy. So I'm worried about eroding away the copper, even though the copper does last very long in the EDM machine. We've got kind of precise spacing that we need. So I think I'm going to opt for a thinner piece of copper like this, and we're going to bolt this piece of, we're going to remove this structure and then bolt this piece of copper onto the side using this set screw hole. So we're going to have an edge of copper here. And then when we're cutting, I'm going to actually advance to a fresh piece or region of copper on our knife here as we cut. So there's going to be kind of a diagonal jog as we go along our row of parts here that we're going to cut out, offering up a new region. So we may have to do this a couple of times because, you know, depending on the length of our copper, that can accurately bolt onto here, because we do want to have this edge to be straight as well, so we don't deviate in the thickness of our little micro spacers that we're going to cut out of this hypodermic needle. So I think I'm going to hack off some copper here and then drill a hole in it and then bolt it right there, probably using a reference plane to set the height. So let's do that. Okay, we're back on the EDM machine for another round of milling. Let me go ahead and turn on the main power to get all the noise going. Bring up the display. I'm hoping we can do all of this in one pass. So we'll stick this guy on our mag chuck and we'll turn on our magnet. Okay, and then we'll, you always want to hold on to the tool before you unclamp it. So we're going to tell it to unclamp. And we pull the old EDM tool out. We're going to keep the pull stud and stick the pull stud into our new tool. You can twist it, and then this little plastic safety retainer keeps it in there. And then we will insert the new tool. So let's see, we're going to go down in Z. Okay, so we'll find the Z height. You know what, I'm going to stick an additional little clamp in there. I've got a little vice grip. Let me be right back. Then we got a indicator here that I usually just mount to the magnet base, which we use to dial in tools on the EDM machine. So if you can see that there. So we'll go up and Z some more. And what I'm going to do here is set the angle of the tool on the end of, and check the flatness of our sheet metal. So we'll come over so we can touch off on that indicator tip. Okay, so now I'm going to basically check to make sure that our tool is square. Zoom in on the dial. So we're going to move X over. Now this indicator is electrically isolated, so you got to be extra careful because the machine will not sense a contact because there's no circuit to close. And this is a 10th indicator, so it's fairly accurate, or well, very accurate actually. We're going to be rotating this tool in the spindle to square it up. Okay, there you can see we started touching. So that would tell us, and actually it started touching right in the middle, which is kind of a lucky, or close to the middle, which is a lucky thing, because now we don't really have to set that location, but we do need to rotate the tool holder until the copper sheet is parallel or perpendicular to the tube that we're going to cut. So I'm going to move over all the way to one end, and we'll watch the needle. Okay, we bottomed the needle out there. So now what I'm going to do is start rotating the axis of the tool holder, and ideally we'll start to see that needle move. So we're going to search to see until we see movement. There it is on our indicator. And we can indicate back to 0, and then so I changed the angle of the tool by 0.3 degrees. So let's move in Y some more to see how we're doing on squaring up our piece of sheet metal. And yeah, so at the end there you can see some deviation in the flatness of the sheet metal where the dial changed. So let's move back. And then we'll go across. So that's plus 1 thousandths, minus 2, 0, and then minus 2. So we're plus or minus 1.5 thousandths, or about, let's see, about 40 microns or so. So I think that's as good as we're going to get with sheet metal. Okay, let's start cutting in a 45-degree angle. So fresh copper on fresh steel every time to have a nice repeatable cut. And the program is started. And soon it's going to raise up the tank, fill the EDM chamber with EDM oil. Hopefully the tank doesn't cut off the view. Nope, it didn't. That's good. Load up with oil. When you're EDM cutting, you have to be submerged in this real thin paraffin oil, or EDM dielectric fluid is what they call it, so that the spark control is correct. It needs to be under oil. And your cut needs to be completely under the oil so that the sparks don't catch the oil on fire on the surface. So that looks good. Okay, so I'm going to zoom in. Here we go. Okay, so you can see our electrode is bouncing away there and cutting through our little fixture and our hypodermic needle at the same time. I can turn the light off, maybe get a better view. And there it goes. So it should be about 6 minutes per tube, and let's hope our little parts remain intact. Alright, so it's been a few hours of running, and I think we've got a success here. I used the dyno light to get a microscopic image of our tiny little spacers, and it looks like a success. So this is a view with the microscope of what the little tubes look like and the pinchers on top of the tool vise. And here's the smallest jeweler's screwdriver I could find to try to pinch one of the, or to bend one of the pinchers open to see if the tube is free. And thank goodness it is free and coming apart, and looks like pretty good EDM finish on the tips. And then the next picture here is a top view showing the vise opening, and our little cylinder there, the one that we bent open, you can see how it fell through the vise, which concerned me a little bit. But then I saw that the rest of the tubes remained on the little tines. And then here I'm measuring the thickness of the tines, which is equivalent to the thickness of the tubes. And we got 1 millimeter or 39.5 or 40 thousandths. This is something that probably needs to be taken apart under the microscope, so I'm going to pull this guy off. All right, so we're over here on the bench. Okay, our little paper catcher is set. So let's go ahead and open up this vise. I'm getting pushed up against the delivery time, of course. A little wire fell off, and it's completely EDM cut through, so that's good. And then we'll just gently open this so that we don't lose 20 tiny micro parts. So let me pinch, pull, and stick to the side, and see if all of our little beads are still around. I hope they're not like buried inside of this vise, but it may be the case. Nothing on our wavy parallel. Okay. So let's see if they're stuck still on the piece of stainless. We'll come up onto the camera. Oh yeah, well, that's nice. They're all still stuck on the teeth. That was very pleasant of them. So I'll just roll them off. Here, let me change the view of the... Okay, so now we'll just roll these parts off. I wonder if they're actually... Oh, it feels like they're actually centered on a little bit. Maybe some of the spark interlocked on the tube with the spark on the or the rough structure on the little support fingers. Oh yeah, there's our. And that was all of them. See this one here. Whoop. Machining the world's smallest parts. Well, probably not the world's smallest, but pretty small when I can't really even see them. Let's make sure there's none there. Okay, so these are our machine parts right there. All right, so after ultrasonic cleaning, these are the end results. I laid the parts on this penny here so we could look at the dimensions and the quality of the ends. So the EDM finish looked good. There's still a little bit of pitting, which happens from EDM milling, but the dimensions were 1 millimeter, and we're ready to ship these off to the customer. So thanks for watching Dragonfly Engineering, and stay tuned for more episodes.